come here and give a talk, which I hope will be interesting to you, because I've taken a look at how all the real-time communication architecture is put together. And you look at all the different diagrams, and it's got the stacks and the processes and the protocols of how it all is put together, which is great. And then there's this tiny little line underneath that is the link between the user, the person on the phone, and the service at the other end. And, well, how do they get there? There's lots of different ways. You can get there over 4G, 5G. You can get there over a copper line. You can get there over fiber. So what I wanted to do was talk today about what we're doing as Barn, Broadband for the Rural North. Just about half an hour up from here is where our network is. And what we're doing in putting our own network in, fiber network, and how that relates to the communication for all the different applications that people use. Okay? So this is a little bit about Barn. We started in 2011 when there wasn't really any fiber going on for residential in the United Kingdom, right? So there was copper out there. There were lots of different projects to put the next generation of copper network in, fiber to the cabinet, right? Which back then was absolutely fine. It was, promising X, Y, and Z. It'd be brilliant. But actually, we believed that fiber was the only way. And as Dan said, we install in quite an interesting space. We are deep rural. So not just rural, the deepest of rural. And what I mean by that is you'll go to a little village, and there might be 50, 100 premises in that little village, which fiber to the cabinet could handle, no problem. But what about the farm that's a kilometre away? Or what about the youth hostel that's a little bit further? Or what about the next farm, and then the next farm, and the next farm, all the way on the moor side? How do you reach them? Right? So 4G and 5G, by the time you get to these folks, you've already gone through 3 or 4 masts to get there, all right? And trying to fiber backhaul those masts is hard work. So the person at the end isn't really getting a very good service. And low Earth orbit has started to pop up at the moment. But still, low Earth orbit, what's that able to provide? Well, about 150 meg at the moment, with reasonable latency, but you're still in the 30, 40 milliseconds. Anyway, going back to Barn, what we decided was full fiber's the way, right? And the only way we were going to do it in these communities is to completely involve them, bring them into the company, absolutely. And they become the company. So we are registered as a community benefit society, and what that means is that we're not a commercial outfit out there to make a profit. Actually, what we're out to do is serve the communities, right? So they have buy-in. So they invest in Barn, in the company itself. And by doing all of this and bringing them in, and they volunteer as well. They know all the different landowners. They know all the different aspects of the rural space. So bring them in. And that's what we've done. And the mission remains at the heart of what we do, which is to deliver the best internet service in the country, we believe, to the areas that are the hardest to reach. So we make the point of going out to the furthest farm. I think the longest line we have is 6.5 kilometers of fiber just for one farm. And that was just up the moor side, just kept on going all the way to the top. But we did it with full fiber, so they can, they have no power up there, they have no gas or anything else, but they do have gigabit fiber broadband, right? Why not? So that's all part of being the community. Include everyone. Don't leave anybody out. And so that's our mission. So on the bottom right here. I think it's quite impressive numbers that we've managed in that time since 2011. We've actually got 5 million meters of fiber in the ground. And the point is that it's in the ground, it's not on poles. We do everything underground, okay? And we offer a gigabit symmetrical service. I'll talk about that in a little bit. So gigabit down, gigabit up. We've got 12,000 live connections on the network right now today. And we also support community assets, so village halls, schools, churches, anything that the community wants to support as an asset. We've got special schools as well on, and we do it for free. So they just get the service, no problem at all. Get the support from our teams, and they can have the service. Okay? So technology choices. As I said, we have full fiber all of the way, so we don't have anything else in between. It's very simplistic by the design. You'll have probably heard about PON or GPON or XGS-PON. So that is passive optical networks where they split, so they can have less fiber in the ground, and you split your signal, essentially, to connect multiple properties, but then that's to the detriment of the service that you can provide. Okay, everybody's still in this mindset of the download is everything. It's not everything, right? You might have a gigabit download, and you might have a 100 meg upload. Sure, that's okay for now for what people need, but what we believe is symmetrical. The upload's just as important as the download when you're trying to have communication going. All right, and yeah, it's future-proof, and we have a proactive approach to it all. So we don't, the design is out there to build in the resilience, build in the redundancy, rather than just doing it as cheap as possible. We do it so we can build it once and never have to touch it again. So a couple of speed tests there. The middle one, that's a 10 gig service. That's people getting 9,438 megabits down, 9,006 megabits up. Not too bad. And it's very simple. So for that user, that goes into the router, back down the fiber, which I've got a little overlay of the individual fibers themselves. They're really tiny. Going into switch goes back to the main core goes out to the main data centers, which, again, I'll talk about in a minute. And then a mobile speed test, 745 meg on a mobile. Not too bad. So I want to talk about building the network. When people think about fiber telecoms, they think of massive trenches, massive ducts, maybe 4 ducts, and then you draw in everything into that, and you make an absolute mess. Well, actually, the picture in the middle there is a vibratory mole plow, it's called, which is where you have your duct system going into the back, and the plow blade does this, and it basically cuts the grass, it cuts the ground, and then it leaves very little behind, just a little cut, and then you can roll over that afterwards and make it good. And then on the right-hand side, that's how rural we are, okay? So there's the hillside, here's the machine working, and that's going across farm to farm to farm to farm. And then the ducting below there at the bottom, that's all it is. It's only that, 16 mil in diameter for the main core. That can hold 288 fibers. Absolutely fine for the rural space, no problem at all. And your 7 mils are even smaller, and that's the customer drops. So putting 2 fibers into every customer. And of course, we get met by all the locals. So we have the cows sniffing into a chamber there. We actually do have a little electric fence, that portable one that you can put out. So you've got your splicing table and all the rest of it. You put this out, and the cows are just watching you. They're just watching you splice, which is great fun, right? I would rather be out here than living in the city, right? So you go out, and it's just an amazing landscape to be in. And then this is the customer side. So, as I said before, we take the fiber all of the way. So the only connector is in the customer premise and in the cabinet. Everything else along the way is spliced. Right? So splicing is where you fuse the 2 fibers together, and a lot of other companies try and remove some of the splices for speed of deployment because splicing is expensive, and so they have connectors everywhere. So connectors introduce loss, all right? Especially if they're not clean. So what we decided to do was actually train all of our folks to be able to splice. All right, so let's invest in that so they can all go and do any splice on the network from cabinet all the way to the property. So you can see here, this is how rural it is again. That's a splice enclosure on the right being put together. And yeah, basically the chambers just below them, they pop up and they splice. It takes a couple of hours to do, close it all down and disappear off, and it's done. Okay, so that was a bit about building the network. I skipped over quite a lot of the other details because it's, this is probably more interesting on the technical side of what we do. But please come and find me if you're interested in talking about the build of the network and how we do it compared to other altnets. We don't tend to go in the roads. We tend to go in private land, agricultural land, etc. It's a totally different ball game than trying to go in the roads to all of these, because that would just be astronomically expensive. Anyway, operating the network. So traditionally what you get, before I go into this, is you have companies that build the network, and then you have companies that operate networks, right? So you have all the infrastructure builders over here, they're putting fiber in the ground, and then they'll partner with somebody to provide the internet, right? So that they might get talking or somebody to then run the ISP network. So what we're doing is actually doing both. So we install the network and we operate the network. So we are our own ISP, okay? And we made the point of getting fiber all the way, so we're in all the major data centers. Okay, so we're in London, we're in Manchester, we're in Leeds, we're in Newcastle. We've got a link still up to Scotland as well. So we're in all the major UK data centers, and we have dark fiber that comes into them all, right? And that dark fiber, and I'll explain in a minute with the project that we're running, that goes all the way to our consumers, right? With very little hops, very little equipment to pass through to actually get to the end users. Because really, when we're talking about high quality, low latency networks, you've got to cut out all the middle, right? You've got to be as short a path as possible to your consumers. That's what I believe anyway. So the ownership and control. So from the transit and peering and the content servers, right, all the way to the CPEs, the customer premises equipment, we control it all. We control the entire path, right? So what I mean by that is in other scenarios, you might have third-party circuits in the middle. So you might have a fiber circuit, you might have a microwave circuit, you might have a different operator here that gets you to this point, and a different operator that gets you to that point. And this circuit is slightly different to that. So this is the latency, the jitter, the delay on this one, and then you've got this to deal with on the other one, and there's a problem somewhere, right? So how do you deal with that problem? Well, you've got to figure out where it is, what operator it's on, phone their support team, and try and get that fixed. And time is ticking when you've got issues like this. So having full control of that entire path, I think, is really important. Because then if you have a fault, and I'll talk about proactive monitoring in a minute, you can find it, you can have the control to be able to fix it within your own timescales and get it done. So what we've done is we've built in the capacity for burst events. So these are things like, the football's on, and the football is now starting to come down your fixed line rather than it being through satellites. And then Apple released an update for your iPhone. Or it's to do with gaming nowadays. So gaming, the kids are deciding, I don't want that game anymore. I want a different game. Oh, well, they just throw that one off the Xbox and download the next one. Oh, it's 250 gig. Yeah, no trouble. Down it comes. And so if a new game gets released, or it's pre-release and everybody's downloading it before it goes live, actually we need to cater for that. And you can see the spikes. You can see when these things happen. And the network goes, right, OK, I'll serve all of that, and then I'll come back down again. But it's quick. So that's burstable. And then the future expansion, just making sure that whatever you're buying has the line card space. It has everything available to it that you can expand into it. And I put a note here at the bottom about symmetrical paths, because asymmetric network routing, to me, is a real pain. And that's where you have your outbound traffic going this way to your end user, and then the inbound goes all the way around somewhere else to then come back. And then well, hang on a minute, why have I got a problem with this link? Why can you see me and I can't see you? Why have we got a delay here but not that way? And if it's asymmetric, it means that it's going one way to somebody and then coming back a totally different way, different transit providers maybe. So being able to control the path to say, well, I'm sending the traffic that way and I'm making sure it's coming back the same path, you're in control, right? And that's really important when you've got really sensitive traffic going on, which is, your VoIP calls, your live video calls, etc. You have some sort of issue along the way, and then you get a stutter, and you think, nah, that's no good. So there's examples on the right here. This cabinet with the yellow cables is the distribution to customers. So each of those fibers is an individual customer, right? And then the switches are at the top, and those trays in the middle are the termination of all the fibers that then span out from the cabinet to all the different users. And on the left-hand side, just at the bottom, is an example of a data center node where you've got the main cables coming in, and then you've got all your main links, which tend to be 100 gig, and I'll talk about 400 gig in a minute, and they come in. But this is where we operate the distribution, we operate the core. Talking about monitoring and telemetry, right? So this one's a big one for me because you can outsource a lot of this, but we think, well, actually having all of that control in-house, you build your own systems for your needs, right? Instead of trying to buy something in, that then you say, well, I need this, this, and this, right? And I need it delivered in this way, and you give that out, and then you get something totally different back, and you think, right, that's not what I asked for. I've got to try and deal with whatever we've got and make it work. Whereas if you've actually got your own guys that you bring in-house and you bring the skills in, because this industry, it requires a lot of skill, right? You guys will know, because you're all in the industry. It requires a lot of skill to bring that in and develop these systems, develop the products. So we believe in open source software. We believe in building it and coding it and giving back to the community ourselves. So if we're coding something, LibreNMS is a good example. That is network monitoring system, right? So if we have a requirement and then we code it internally, we'll give that back to the community. We'll put that back as a push request and say, here you go, there's this now ability to be able to do this in this system. And we do the same with all the others wherever we can. So there's some examples on the right of how we use it. So the top one is Grafana showing us the health of a cabinet which has got the battery system in it. How long is it going to run for? 18 hours if there's a power outage. Great. Okay, what's the battery capacity like? What's the input voltage like? What's the output voltage like? When were the batteries last replaced? And I could just go on, what are the fans doing? What rates are the fans spinning? Is one broke? Is one not broke? Is the door open? Is it closed? If you proactively monitor all of these things, when something happens, you'll go, that's where it is. Okay, and that's really, really important. And that's an example of us using these systems for physical infrastructure, right? Actual fibers in the ground, and cabinets to look after, and people to look after, right? There's also monitoring on the inside of all of these, in the servers that we run, and I'll talk about Linux containers and all the rest of it in a minute, and something we're doing with Anycast DNS. Right? So you've got to monitor all of that. You've got to monitor your services. Is something going wrong on the inside? Because if it is, you want to know about it. And the team are like a hawk. They're looking at all of these things to pick them up. So another couple of examples at the bottom. Genie ACS, that is an automatic configuration server for all our routers, right? So we can code in, well, we want the router to be able to do this, or add this function to the end user's router in the house. Great, okay, let's push that. Out it goes, and then you can push things out there. One example, I was talking to the SIPGate team this morning, right? So at the moment, SIPGate is used quite a lot on our network, and we can actually help users get there by helping them configure their routers, right? So we can push these different things out and get the responses back of whether it's stuck or not and all the rest of it. So very, very useful tools. And then there's a couple of examples of what a traffic profile looks like at the bottom. So the small peak is in the morning, so that's sort of 7 in the morning, everybody gets up, traffic starts to flow, nothing much in the day, and then everybody gets home from school and work, and it goes whoomp right away until about 11 o'clock at night, and then it tails off. You've got your gamers until about 3 in the morning, and then it tails off, right? But you can see what's happening, which is really, really interesting. Totally different to a business graph. A business graph would be everybody gets to work, flat lines till about 4 or 5 o'clock, and it goes dead. But for residential, absolutely you can see it absolutely fly up. And another good couple of examples is where we've got private schools on the network, a boarding school, and you can tell when lights out happened, right? So you can, 11 o'clock, exactly on the dot, all this traffic, and it goes zoop, straight to nothing, because what they've done is they've said, right, lights out, folks, and they've turned the key and turned it all off. Anyway, back to all the systems. I believe open source is the way to go. I believe having an in-house team and training people, bringing the skills in, sending them all the training courses that they need to go on, and rather than trying to go out to the market and get everything from the market. Of course, there are things that you need. You need to bring in consultants, you need to bring in systems, fine. But I do think having a healthy fleet of tools and equipment that you can use on the inside is really, really positive. Okay, on this slide, in this pack, I was going to talk about the copper switch off and what that means. It's worth just telling you what's happening in the United Kingdom at the moment with copper and how that might interact with what you guys are doing in real-time communication. So what's happening? Well, the United Kingdom has copper everywhere at the moment, and this was the way OpenReach, or BT OpenReach, was deploying network in the early days, right? Copper was the only way. Fiber wasn't developed enough. Well, I say that. They actually developed it in the 1980s, and they chose not to use it. But that's another topic for another time. So Full-Fibre is absolutely the way. The United Kingdom has really sort of honed in on that now. You can tell from the bottom here, 52% coverage of Full-Fibre now. You go back a couple of years, and that was 3%. Right? So, and you go back a couple of years, and you look at Spain, and it was 70%. Right? And so we were 3%, and the rest of the world was going, yep, we're deploying fibre, thank you very much. So we're playing catch-up a little bit. So what does it mean for the copper network? Well, Openreach maintain the vast, vast majority of copper network in the United Kingdom, right? And they've announced that they want to bring all that back. They don't want to sell it anymore, quite rightly, and they want to start bringing it away and having Full-Fibre put in. So in the media, you'll have seen this notification saying, well, by December 2025, the copper's going to be turned off, like this massive lever that's going to go like that and get turned off. It's not, because what they're doing is they're waiting for all the fibre to be deployed to then turn the copper off. So they're doing it as a gradual process. It's already been happening. So you can see there, since 2021, Openreach has stopped selling copper products until when an area's got 75% fibre coverage, they stop selling it. They'll keep the lines running that don't have another option, but they won't sell anymore. So it's already happening. You know, there's 2,900 plus locations as of August last year where they don't sell copper anymore. So this is it. It's dying away, I think quite rightly, because Full-Fibre is the way to go. So what are they doing? They're turning off the PSTN network, the public switch telephone network, and the ISDN network, the integrated services digital network. Now these are the older technologies of how you would operate you know, your phone calls, your real-time communication phone calls. And so the way that that stack worked and then plugged into the modern network of communication is quite a big thing. So once that disappears and goes away, we're all using this new technology stack over here that everybody's using already. But it's that in managing, getting rid of all of this, and you've kind of got to wait until the last connection goes before you can really say, right, we're all the way over onto the new system over here. So what we've got to do is we've got to build the systems, code the systems to cater for everything right now for years to come, I think, until all the copper disappears, and just make sure that the older technology of using analog and digital telephone lines with copper can still work with the modern way that the world is going, and getting rid of all of this. So telephony traffic paths are changing. Right, their equipment requirements are different. I mean, I think I put in here that actually they're not selling analog phones anymore. It's all digital phones, right? So trying to really push towards the future. And I think, the industry as a whole, including everybody, needs to embrace all of this and just get on with it, because eventually, whether the December 2025 date comes true or not, it's happening already. It'll just progressively get to the point where copper isn't a thing anymore, and we just need to be ready for it. But some things go unseen, right? We've witnessed things like care alarm systems or care and welfare alarm systems, burglar alarm systems, building lift alarm systems, all the rest of it. The actual units that are used for all of that still use copper. And for example, the care alarms, what they've got is this really fancy digital system that allows somebody, if they're in distress at the house, they can press the button and then it will call out. But what it's doing is it's got this really great digital infrastructure in the house to then convert it in a box to go down an analog line, right? So what it's doing, this box is trying to make a call through an analog, traditional BT Openreach telephone line back to the BT Exchange, which then goes and calls somebody. And what they've done at the moment is, you bring in your VoIP service, it might be SIPGate or Vonage or whoever, and they get an ATA in the house, right? Which then converts the analog signal, etc., into digital over an IP network. So you kind of got care alarm, box that they've got, turn it to analog, that goes into the ATA, which turns it digital to go out on the line. You're thinking, whoa, guys, what's going on here? And it's the same for burglar alarm systems and the building lift alarm systems. These are just some examples. It's also about plant and machinery monitoring. We've got a couple of hydro power plants on net with Full-Fibre, and I've been to a couple of them, and what they're doing is they're putting the fibre line all the way into the plant room, and then in the plant room what they're doing is they're connecting their control panel for the hydroelectric power systems and having a digital output, an Ethernet output that then goes into whatever firewall that they want and then into our internet service. Brilliant, that's what we want. But still a lot of systems rely on the copper network. Anyway, so I think what needs to happen is everybody needs to realize that all of this infrastructure is going to go away, and then we're all coding and pushing towards the future. Okay, example of something we're doing with Anycast, all right? And because we are able to control all of our fiber network and the nodes that are connected, and this is the case of how they're linked together, we control those links, we can actually set things like this up, where what you've got is you've got a single IP that's available over multiple nodes which are meshed together using BGP, so then you've got fast reroute if problems occur on the network. And so me as a consumer, if I want to go and ask, well, where is this website, or how do I get to here through DNS, we can respond to that immediately. And it's just a really, this is the beginnings for us in terms of putting these systems in place. This is the first Anycast system that we've got going, and actually it's working really, really well. You know, these nodes, these 5 nodes here, they're sort of spread over a regional area, and so that customer can go to that one, this customer can go to that one, and they can all come together and get a really, really quick response from our system. All right, so this I think is the future of how the server clusters are going to be built. I mean, a lot of people are already doing this, but it just means that you've got that IP address or service or whatever it is always on, and you can always get to it with the shortest path, lowest latency path. Okay, so now I need to speed up a bit. I'll talk a little bit about our Halo project that we're doing, so you can get the scale from the image on the right. These are the main data centers and how we are connecting together. So you see that northern ring? That's our dark fiber. So this is a pair of fibers in the ground that we're leasing from Zayo, and what we're doing is we're lighting that dark fiber with equipment that we are owning and operating, and then we're plugging in our switches and routers into that. So that northern ring there that goes Manchester, Penrith, Newcastle, Leeds, Manchester will provide that core backbone for the network. And this is where I'm saying, in other circumstances, you might be operating a network in a town somewhere, and you'll use somebody else to get back to your data center. So that is an unknown quantity sometimes, right? You might not know what's going to happen with that circuit and how it's going to operate. Whereas if we look after it all, we can do what we like with it. So here, for example, what we're going to do is put 400 gig technology on it. I'm going to talk a little bit about 400 gig in a minute, because it's really exciting stuff. Like that, and then of course we need to get to London, because that's where most of the content providers sit, and they don't go north yet. Why? We need them north. This is, the likes of Google, the likes of Amazon, Netflix, Meta, all the rest of it. Get them more up north, please, because that's where all our customers are. They're starting to do it, but they need a little bit more. Anyway, we need to connect into London for now. So what we need to do in a project like this is make sure everything is ultra clean, right? We're talking about very sensitive fiber. So when we're running this project, and I know you'll have a similar sort of thing when you're running, whether it's a coding project or whatever it might be, it's the same sort of methodology for it. That you've got to plan what you're doing, really plan, stress test the plan, update the plan, prepared for anything unknown that's going to come, because it will come. And when the teething issues arise, you've got to have a really responsive and flexible team to be able to understand what's happening, what's the solution for it, get the solution out there quickly, so then you can deliver on time. Same thing for any sort of project you're running. But for very sensitive long-distance fiber, you've got to make sure it's all really, really clean. Biggest problem in fiber is dirt. Right, so when you put a connector together like this, some people think, well, it's all right, it's just a tiny little connector, it's just like a copper connection, just put it in. Well, actually, no, it's really sensitive. As soon as you put dirt in between 2 fiber connections, it smashes the glass or it scratches the glass, and you can't clean that off no matter what. So you've got to chuck your cable away and start again. So the thing here is to make sure that you're cleaning and cleaning and cleaning, and then you look down the fiber and make sure it's really clean and plug it back together. All right, so, and then audit everything, I think. You've got to track all the changes, just like you do. I mean, we use Git internally to track all our software changes and everything else. It's really important to be able, the team to be able to manage and look after what's going on. So audit absolutely everything. And then these are the pieces of kit that operate the network. So this is Juniper Networks. You've probably heard of these guys. They're pretty major, and we've been using them since 2011. Absolutely fantastic pieces of kit. You put them in, you turn them on, they just work, and they work forever. So we're going to upgrade using these guys, which are 400 gig capable. And the boxes, and I can't believe this really, 4.8 terabits in 1 U of space. That's about that much space. Tiny little space. 4.8 terabits of traffic could go through that. It's just unreal. So we're going to be using these guys in our network. Again, something that we're going to buy in and operate ourselves, and just gives us a flexibility. These new models have greater telemetry as well. So instead of it being SNMP, where you're sort of polling it every now and again to get information from it, actually live telemetry on these guys is going to be really interesting to go and look at, just to see what's happening with the traffic over the network. So this is the interesting thing. This is my last slide, don't worry. Interesting thing here is the 400 gig technology, right? So, the industry at the moment works very much on 10 gig, 100 gig, all the rest of it, where you got your traditional send a bit that way, you get a bit back, you send another bit, you get it back, you get it, all right, and 10 gig works that way. Whereas what they've managed to do, and this is magic, absolute magic for me, is what they've managed to do is, you see the little diagram in the middle there, which is the circle. What they've managed to do is split the signal into different quadrants, right? So if you're sending signals that way, you can also send signals that way as well, and you can send a signal like this and split them up. So these signals are going here, these signals are going there, and you can do it on both planes. And so basically you've got 4 quadrants and 16 different paths that you can send the traffic down. It's just magic, and all in a pluggable form factor optic, right, which is about that big. It's tiny, and they've built all of this technology into this tiny, tiny little module. I mean, I remember deploying networks 15 years ago where a box about maybe this big or something like that had to go in a rack. You had to sort of like get a truck because it was so heavy and pump it up and then put it in and screw it in, and that would do you 10 gig. Whereas now, this is available, and it's just magic. So that top unit there is the fiber drivers, right? So this is not the routing equipment or the switching equipment. This is what drives the light over the fiber. And there's 40 channels there that can run at 400 gig in 1 U. It's just magic. So these are the guys that we're going to put in the network. And we're going to run a single 400 gig channel to begin with, which will absolutely cater for the network size today, no problem at all. But it just gives that expansion if you want to put another 400 gig in. And a lot of data center operators, like D6 and Lynx and all the rest of it, they've already got 400 gig now. They've already got this in the data center, which is linking, the major operators together, like BT or Zen or whoever, linking them in to Amazon and all the rest of it for all their web services, because traffic at the moment is just going on the rise. So just very quickly, this diagram on the right here is showing the sort of the distance, not the distance, sorry. It's the size of the bandwidth that you need to send 400 gig down a line. The 10 gig is over there. On the left-hand side, it's really, really tiny. And on the right, it's very, very big. And within that, obviously, they're splitting it as well. But it means that the old technology was always set up for 10 gig, where the channels were hard-coded, 40 channels hard-coded to a certain bandwidth level. And so you try and plug in a 400 gig now, and it won't work. So you've got to change all of your gear to allow for this bigger bandwidth on the network. And it's going to become the norm, I think. I think a lot of operators and people are going to start to all adopt this, put it into their networks. And yeah, you've got options. Here, this is where you've got a 400 gig coming in, and you can split it into 4 times 100 gig. All right, and you can just start to deploy your network any which way that you want to. Anyway, it's just magic. Come and talk to me if you want to about any of this. Obviously, I'm quite passionate about what we do and how we do it, and just operating the network from ground up. And yeah, it's just, this is what we like to do to try and make sure that we give the best service to the consumers that we've got at the end, because we believe in making sure that that path is the shortest it can be, it's got the lowest latency that we can, it's symmetrical as far as we can make it, so their experience of whatever it is that they're connecting to is the best it can possibly be. Right, so that's it in a nutshell. Thanks to Dan for inviting me. I hope you enjoyed that. And any questions? We have a couple of questions. I think there's a microphone roaming around.
Hi, Tom.
Hello. Yes.
Hello. Hello. You're one of the few providers still rolling out symmetric switched Ethernet right out to the
Correct.
edge with active cabinets. Most even new altnets now are doing various varieties of PON up to
Correct.
XGS PON. Is that something that you think you're going to be able to continue? Is that a sustainable model? It's great from a customer point of view because it gives you a symmetric path all the way in. But is that something that's going to be sustainable for you operationally?
Yes, it's a really good question. I'm going to say yes, and the reason I'm going to give is, sure, there might be savings in less fiber and splitting out your networks, but that's great for an area that is quite dense, because you can go to a street and you can take a single fiber there and split it 18 ways to all the different customers on that street. Whereas for what we're dealing with is one fiber line could go 500 meters for the first property, kilometre for the next one. It could actually go up to 15 kilometres out on the main line to go and reach the next customers. So you can't really use PON for that, because you'll be going all the way out there to split that network up into 18 when there's only 3 customers. So we believe that the method we've got is that all of the switch ports can be used for whatever distance our customers are, and we're not having to then put lots and lots of different splitting nodes in. So yeah, it's more expensive. The manufacturers are still producing the pluggable optics, the switches to be able to cater for all of this. I know there's a lot that go down PON, but there's still the manufacturers that do point-to-point Ethernet. So yeah, we believe it's the way forward for the network that we're deploying, deep rural. Okay? Couple more questions.
So, from what I understand, you're putting trenches and laying the fiber right in the middle of fields,
Yes.
and then covering it up, and they're pretty much unmarked.
Yep.
Since these are just fields that can be plowed and stuff, do you get a lot of problem with fiber cuts? And if so,
It's a really good question. It's a really good question. So the way we get around this is knowing what the land is being used for, right? So because we know the landowners, because it's part of the community, what we say is, right, well, where do you plow, where do you subsoil, what crops are you growing, what's used for grazing, and then we can choose the path that goes through the least disruption. And what we tend to do is follow the hedge lines, the fence lines, and land that isn't really used or couldn't be farmed in any other way because it's awkward, and that's where we tend to go. And when we do have to go in fields that are subsoiled, which is where you have a machine that rotates the soil every year, is sort of rotate it one way, and the next year they rotate it back, and we just go low enough that we're out of the way. So yeah, if you just ploughed it in and didn't pay attention, then actually, yeah, you'd get cuts all over the place. But if you talk to the landowners and figure out where do we put it, so it's out of your way, then we obviously get cuts because farmers forget, but it's very minimal. For the amount of network we have very minimal cuts to the network. Okay, another question over here. Thank you.
Thank you. I have a couple of questions. First of all, maybe I missed that part, but how many customers do you have right now?
12,000 connected.
12,000 connected. And how much are they paying monthly?
£33 a month.
How does it compare to other broadband companies in the UK? I have no idea.
That's for gigabit up and gigabit down, by the way.
Yeah.
So
what would you pay for the same service in London, for example?
Probably 70, 80 quid, something like that.
Okay.
Yeah. So for the service we provide, your general, if you go to BT Umper or whatever, you're paying minimum 60 odd pounds. They've got all these offers, £1 a month for 3 months, and then it'll go up. But yeah, we just £33 a month. That's all we need. And
the last question is, I'm really curious, what do farmers do with all this bandwidth?
Well, I'll tell you what.
Are they Netflixing all the time, or are they FaceTiming all the time?
It's a question we get all the time. It's actually not about the bandwidth. What it's about is availability and a high-quality connection. Because what farmers have to do nowadays is they have to submit their cattle movements online, and they've got to do it in a timely fashion. And there's all of these different government schemes out there about how they're using the land, what they're using it for. And so they've got to communicate with the government services all of the time to be able to get their basic rate payments or whatever scheme that they're on. And if they can't do it, then they're missing out on income for their business. So the fact that whenever they sit down at their computer and they go, right, submit cattle movement, it just works. Right, so no need for the bandwidth right now. It has to be always on and available, and that's what they go for. Does that make sense?
Well, it kind of does. How do I become a farmer?
Now, to be fair, though, we do have small businesses out there that usually used to commute to the cities, like Manchester or Leeds or whatever, and actually they can work from home now. And what they're doing, these are like photography companies where they've got gigs and gigs of photography files, raw files that they need to send up, bring that down, edit, send up, bring that down, and again and again and again. And that's what they use the bandwidth for. So we've got lots of small businesses that can actually operate from home with a nice picturesque, view outside.
This is more of a comment than a question. Does this mean that faxing is finally dead?
Say again, sorry?
Does this mean that faxing is finally dead?
Faxing. Yeah, I'd hope so. I'd hope so.
When it comes to monitoring, how do you decide what to monitor? Because you ever run SNMP walk on a Junos box, you get back 1,001 responses. Sorry, how do you decide what's important to monitor and what's noise? Like, what do you decide what's important to watch?
Yeah, no, that's a really good question as well. And yeah, at the moment we do snump all of the devices, and what we're really interested in is how that piece of kit is it healthy or not? As in, what are the traffic levels? What's the CPU doing? Even what the power draw is, and all of this sort of stuff. So you can manage that device. You can get nth degree of information back from a device, but for us, it's all about how can we make sure the consumer is getting what they need. So are there problems? Is there a broadcast storm brewing somewhere? Is there something going on? We need to detect the problems and go fix them before they happen. Right, so those are the sorts of telemetry things we're interested in. But yeah, you can get all sorts of data out of these devices. Yeah.
You said when you were doing the CPE installation, you put 2 fibers in, but it's a simplex fiber.
Yeah.
Is that just a spare because it's cheaper it's more cost effective to do 2 splices at the same time than to have to come back and replace it if there's a fault?
Very good question as well. What it boils down to is actually when you buy the fiber itself to go into the properties, it's the same price for buying 2 for 1. So, putting your 2 fiber in, it gets you that extra fiber that we're not currently using, but actually it's the same price as trying to buy that same with 1 fiber in. So there's no cost difference, but it also gets us a second fiber at the home. Now, interestingly enough, in the early days of 5G, we approached the government and said, look, actually we've got all this extra fiber on the network that's separate to the residential users' fiber. Could we do something there? And so the thought was that you could use that second fiber to put 5G small sectors on different buildings in these rural communities, and then they could be used to put the signal out of there, right? It never happened, but things like that, second fibers are really useful.
It's not just for if there's faults, you can just swap it.
Well, they do that as well, but yeah, it's not for that. It's just use the main line, and then the second line could be for anything else. Right. Any other questions? Yeah, thanks again, Dan, for inviting me. Really good. All right.
Thank you very much. Thank you to Tim Panton for making the introduction, because without Tim, we wouldn't have thought to talk to Barn.
Very true.
So thank you very much, Tim. Edge compute is like, this is the thing that I really want people to think about here.
Yeah.
Is making relationships with companies like yourselves.
Yeah.
Like, media needs to get more and more close to the consumer.
Yes.
And we've got Netflix caches and whatever else to be able to handle people watching the same thing, but not, going back all the way to Netflix and asking for it from Netflix.
We have those.
But that's Netflix scale, right? But it's still important for us in real-time communications to be able to make these relationships with ISPs, no matter what the size is, to be able to kind of push forward what we're doing.
Yeah, I 100% agree, because it's that path in between. If you can make that as clean as possible, then that's only going to help.
Yeah. Thank you very, very, very
no problem.
much.
Thanks, folks.
So I read an interesting number last week, and I've just been looking it up again. BT, as Tom said, are getting rid of PSTN. And so BT have opened up a program, where is it, called the Exchange Clearance Operation Program. And they think that they're going to remove 200 tons of copper from their exchanges in 2023. If you think 1 kilogram of copper is worth £7, then that could mean that all of the copper that's coming out of BT exchanges this year is worth £1.4 billion. And that's just this year. And BT are far from done actually like removing PSTN, which then allows them to remove copper from exchanges. So that number could grow quite exponentially over the next couple of years, which is very, very interesting. What's even more interesting is they're not touching my exchange for the foreseeable. So I'm reliant on people like Tom coming in, wink, wink, nudge, nudge, to give me Symmetric. Couple of notices. So we've got the Tele and we've got the Element sponsor rooms. If you haven't already gone and seen them, then you should. And then we've got the Everycast Labs t-shirt that a couple of us were wearing yesterday. These are going to be on sale today and tomorrow. Today after afternoon tea, because I know some people have to leave early-ish tomorrow. So they will be available probably in the conservatory area after afternoon tea today. I'm not sure on the final pricing. No, I am. No, I'm not. I'm not willing to commit to a number up on stage. If you're interested, come talk to me. But we'll be selling them tomorrow as well. I think that's all of my notices for today. So have a great day 3, and we will see you for afternoon tea and coaches to Blackpool later. See you all later.